Let's look at OpenStack's College Physics, Chapter 23, Problem 96. To receive AM radio, you want an LRC circuit that can be made to resonate at any frequency between 500 and 1650 kHz. This is accomplished with a fixed 1 microhenry inductor connected to a variable capacitor. What range of capacitance is needed? So let's write down the things that we know and what we're looking for. So we know that the range of frequency is between 500 kHz and 1650 kHz. Then we know that the inductance is 1 microhenry, and we're looking for the capacitance range. Now for the diagram, we basically just have an LRC circuit, so something like this. And we want now to find the capacitance so that the circuit resonates with a frequency range from 500 to 1650 kHz. Now, resonant frequency is given by 1 over 2 pi square root of LC. What we know about resonant frequency is that for that frequency, the impedance in the circuit is minimum, so that means that the current through the circuit is maximum. So that's what resonant frequency is. So from here, I know everything except for the capacitance, so capacitance will be 1 over 2 pi frequency quantity squared times inductance. So we have to apply this equation to the two different frequencies, the limiting values of those frequencies, to find the limiting values of the capacitance. So for the first frequency, we have C is 1 over 2 pi times 500 times 10 to the third hertz, and we have to square this, times the inductance, which is 1 times 10 to the negative 6 henries. So this will give us 1.01 times 10 to the negative 7 farads. And for the higher frequency, we have 1 divided by 2 pi times 1650 times 10 to the third hertz, quantity squared. And the inductance is 1.00 times 10 to the negative 6th. So that gives us 9.30 times 10 to the negative 9th farads. So that means that capacitance range for which this particular radio can get that station is between 9.3 times 10 to the negative 9 farads and 1.01 times 10 to the negative 7 farads.